Yes, dear students, you have now known electric field due to a single plane charge sheet. If it is a single plane charge sheet, that don't think that is a metal sheet. It is simply a membrane of charge. Then field near this point is equal to last video 2 sigma upon epsilon 0. Now, if there are two plane sheets, actually sheets are like this, but we show here like this. These are two plane sheets for simplicity. Actually, it is difficult again and again to draw this figure. So here, suppose we have two plane charge sheets. Simply don't think these are metal plates. This has sigma 1, sigma 2. Now there are points P1, P2 and P3 just close to the sheet. P1 in the left, P2 in between and P3 in the right. So electric field due to the sigma 1, it is positive charge, so it will be pointing this way, E1. And field due to this also this way. I have placed the heading electric field due to two parallel and closely placed charge sheets. The distance between them is not very large in complete size. So these two fields here are from right to left. Here sigma 1 will produce field this way, E1, and it is E2. Here both field will be E1, E2, same direction. Now fields here have two directions, one left to right, one right to left. So taking the convention, electric field or direction from taking left to right direction, left to right direction, positive, and right to left and right to left, negative. Remember, electric field is vector quantity. Direction is important here. So direction of electric field is direction force on positive charge. If this plate has positive charge, then if we place trace charge positive, it will repel. So here two fields, and field due to single plate sigma upon epsilon 0. Since these two fields are from right to left, so electric field at point P1 due to two charge plates that equal to minus sigma 1 upon 2 epsilon 0 or minus sigma 2 upon 2 epsilon 0 or minus 1 upon 2 epsilon 0 sigma 1 plus sigma 2. Magnitude. If you want to write vector form, then vector is equal to minus 1 upon 2 epsilon 0 sigma 1 minus sigma 2, where n cap is vector whose direction from left to right. N cap has direction from left to right. Student get confused, sir. चार्ज नेगेटिव पॉजिटिव है, इलेक्ट्रिक फील्ड नेगेटिव हो गया, क्यों? क्योंकि इलेक्ट्रिक फील्ड डायरेक्शन फोर्स पॉजिटिव चार्ज, ये पॉजिटिव चार्ज प्लेस रिपेल्ड फ्रॉम राइट टू लेफ्ट, है ना? एंड हियर राइट टू लेफ्ट, left right. So there are two directions. our convention is this here, taking direction left to right positive, right to left negative. Due to this convention, we have minus sign, or minus sign indicate here that field are left, right to left. Now at point P2, P2 in the between the two plates, at point P2, E equal to, I should write directly vector form, sigma 1 upon 2 epsilon 0 positive E1 minus sigma 2 upon 2 epsilon 0 n cap. Again n cap, the same unit vector pointing left to right. Origin 1 upon 2 epsilon 0 sigma 1 plus minus sigma 2 n cap. Magnitude simply 1 upon 2 epsilon 0 sigma 1 minus sigma 2. So it is the magnitude of electric field in between. Here I write equation 1, equation 2. Now at point P3, both the field due to the two sheets are from left to right. So at point P3, E is equal to, in vector form, sigma 1 upon 2 epsilon 0 plus sigma 2 upon 2 epsilon 0 n cap. Or magnitude, you can write E equal to 1 upon 2 epsilon 0 sigma 1 plus sigma 2. And you must remember that what is sigma here? Sigma is the surface charge density, charge unit area on the sheet. So this is equation 3. Now we here take some other condition also. What is those condition? Conditions are like this. Okay, if sigma 1 is equal to sigma 2 is equal to plus sigma, means both the plates have equal and positive charge density, then at point P1, E is equal to minus sigma upon epsilon 0. Sigma upon equation 1 यूज करें ना भाई, डायरेक्शन राइट टू लेफ्ट. At point P2, E is equal to 0, because their field is 1 upon 2 epsilon sigma 1 minus sigma 2. Sigma 1 is equal to sigma 2 is equal to sigma. At P3, at point P3, E is equal to sigma upon epsilon 0. Means if these two plates have plus sigma charge density, so here field is like this. But remember, this formula are only up to small distance true. At large distance not true. People are confused about this short and large, and here zero field. This field is sigma upon epsilon 0 minus का, and here E is equal to sigma upon epsilon 0, but here it is 0. Between the plates now it will be 0. Now if sigma 1 is equal to plus sigma, ये condition 1 थी भाई. Condition 1. Condition 2 क्या है कि if sigma 1 is equal to plus sigma and sigma 2 is equal to minus sigma, then field at point P1, P2, P3. You remember ना point P1, P2, P3 कहाँ हैं? Here point is they are present plus sigma minus sigma. Point P1 here, point P2 here, point P3 here. In this case, at point P1, at point P1 is equal to 0, क्योंकि पॉइंट P1 पर फिर था ना इक्वल टू माइनस सिग्मा नहीं माइनस 1/2 और सिग्मा 1 प्लस सिग्मा 2, तो सिग्मा सिग्मा और सिग्मा 2 माइनस सिग्मा तो 0. Here field is 0 at P2 at point P2 means in between the plates E will be equal to sigma upon epsilon 0 pointing from left to right, not like this. And this field is supposed to be constant throughout, uniform field at P3 at point P3 is equal to 0. This fact actually is used to produce uniform electric field between the plates, but this field is true uniform near center, outside field line like this. Why it is so? Because I told you that E equal to sigma upon 2 epsilon 0 is the field due to plane charge sheet, and it applies only when distance of plane sheet is large enough than distance of the point P. So here, and you learn next chapter, capacitor. Remember this formula there. P equal to sigma upon epsilon 0. Sigma is equal to charge upon area. So this was the application of electric field due to plane charge sheet, and then to plane charge sheet. Now there is a single problem which makes you think more clear, which you have learned now. Gauss theorem says that an electric flux through closed surface will include some volume V is equal to total charge inside divided by epsilon 0, or surface integral of electric field. Surface integral of electric field over closed surface which includes some volume V is total charge inside is divided by epsilon 0. Now to understand this, now I have seen this example in very standard book. When we start our career, there was book Resnick Holiday by English author. Very good book. Here is uniform electric field. Here is a uniform electric field E in unit Newton per coulomb. Please adhere to the units. Before writing anything, think over what is the unit. There is a cylinder inside this place. Maybe imaginary cylinder, or maybe really a cylinder. The question is that what is the electric flux through the surface? What is the value of electric flux through the surface, through the cylinder? So this cylinder has three surfaces. This called surface I have shown you earlier also कि ये हमारा सिलेंडर है. It is placed in uniform electric field here. This called surface. These are two circular faces, and I told you here we electric flux is E dot A. Why? अगर area A है तो E dot A area. अगर ये area A है ये भी, this will be something. So at this point, electric field is inward but area outward. Diagram is this way. Here both E and A are in the same direction. Here this surface area perpendicular to E. This area, whatsoever it is, I can say A3, A1 A2, they are equal in size. So now flux in the right side, left side, sorry, left surface, it is E dot A means EA cos 180. Why cos 180? Electric this way and area this way. Direction we are right to left. Cos 180 minus 1. So it is minus EA. Now phi right, it is also E dot A, यानी कि EA cos 0. Y cos 0, A and E both are parallel. So it is plus EA. Then phi 3, या phi per surface, it is E dot A, यानी कि EA cos 90, because area element is perpendicular. I show you here. In this cylinder, this area this way, this area this way, electric field horizontally. So everywhere electric field is normal to surface. Surface that is 0. So total flux, phi left plus phi right plus phi C curved surface. So minus EA plus EA plus 0. That is 0. It is 0. In terms of surface integral, I determined this electric flux through this cylinder. But secondly, Gauss theorem states that total flux through any surface is equal to total charge inside the surface. And here there is no charge inside. So phi equal to Q upon epsilon 0. But here Q equal to 0. So phi equal to 0. So this was the example just to explain how to find out electric flux through any surface. E dot A. I should have told you before applying Gauss theorem, but I deliberately did not tell, so that you go back if any confusion is there and see it yourself what to do. I think the things are clear. I have seen many people have seen the video of electric field due to plane charge sheet. I request you please subscribe. If you have not subscribed my channel, subscribe so that whatever topic is uploaded, you may get it at once. And it will help me also to run this channel. This is for benefit of students and society. There are many people who can't go anywhere, like in big cities. Your favorite teacher lives 20 or 30 kilometers away. How can you approach him? And here, I may not be your favorite, but if you look all the videos carefully, then you will like it. Many people are liking my videos. Thank you.